right, so I'm going to change to English. Sorry, I don't know Turkish. Thank you very much for having me here today. It's a pleasure to be a part of the Istanbul Smart Future World Expo. So I personally love working in the world of data. So today, I hope to spark that same interest in you. We're going to focus on the world of big data. So imagine if we lived in a world where every movement, every word, every action, every purchase was recorded. Imagine then if all of these recordings were then used to predict your next move, to forecast your predisposition to diseases, to suggest your lifetime partner, or maybe simply to suggest the next movie you should watch on Netflix. We already do. That's the world of big data all around us. There's virtually no aspect of our lives that will not be affected by big data over the next decade. It's happening all around us. We're accumulating tons and tons of data. But before we get into understanding what is big data, I think it's important for us to understand how did we get all of this data? How have we accumulated so much data? We're all experiencing a digital transformation, both in our personal and our professional lives. But has everything really changed that much? Let's take a look. I'm going to show you some pictures comparing now with the past. And let's try to understand what has changed. So the first picture, this could see, let's say, one day on the metro in China. The next one, this probably reminds you of your typical commute to work in the morning. This one, so the other two I got off of Google Images search. This one I took myself on the metro in Moscow. So you can start to see a pattern, right? Now let's compare this with the past. Here you've got the past. Can you see the difference? Think about it. Now another picture. This might remind you of your typical Friday evening with your husband or wife. And this is the past. Do you see a difference? And this last one, of course, I have to show the famous selfie. And if we compare it to the past, you've got here and here, more of the past. So we can see here that as humans, we haven't really changed our habits that much. What has really changed, and is very important, is the fact that everything is being recorded, because we're now performing those habits in a different way, a different mode, a different form. And this is generating a ton of data. This data generation is what sparked all of this big data talk. Now, while we're on the subject, I wanted to show this picture. You may have seen it before. To the left, you've got two pictures comparing 2005 with 2013. This was the Pope speaking at the Vatican. There is a huge difference, obviously. There is a clear proliferation of mobile. Everybody wants to record that moment and share it. And nobody is really enjoying the moment, right? So this is what's sparking, this is why everyone is suddenly talking about big data, because we're generating it all around us. Not only people, but every object and every organization leaves behind a digital footprint. We're all leaving behind a digital trail. So think about it for a moment. Where are we getting all of this data generation? I spoke about it before, the mobile phones. We're producing a lot of data from there. But as well, you're getting it from other things. For example, social media produces a lot of data. You've got GPS and movement data. You've got health statistics and medical images. You've also got digital music, digital photos, video surveillance, YouTube videos. It's all around us. Now, for you to understand how massive this quantity of data really is, I'm going to focus on an internet minute. What happens in an internet minute? Well, globally, Instagram users post over 50,000 pictures every minute. Google search globally gets almost 5 million search queries every minute. Twitter users tweet over 500,000 times a minute. And lastly, we send 188 emails every minute. This is a massive amount of data, and it's just waiting to be exploited. There's no going around it. Data generation is exploding. The numbers are staggering, and they're not slowing down. By next year, there will be 40 times more bytes of data than there are stars in the observable universe. It's amazing. And interestingly enough, over the last 2 years, we have produced 90% of the data in existence today, whereas the other 10% of data was produced in the entire human history. So if you think about it on a graph, it's exploding. It's an exponential growth of data. Now, I personally do not like the name big data. I think it's very misleading, and it's not so simple. It's not just large amounts of data. So when you hear the word pair big data, I want you to think of complex data. So new data, different data, that's better than any data we've ever had our hands on before. This is my personal definition of big data. So for me, simply put, big data is a collection of data from various sources that, due to their large, unstructured, or real-time nature, cannot be managed in traditional ways. Big data is used to refer to both the exponential growth of data that I just spoke about, as well as the new technologies, the new systems that we have to manage this enormous, this difficult, complex data. We can break my definition down into pieces. So this is the easiest way to explain it, the 5 V's of big data. I'll focus on the first one, volume. This is the easiest one, obviously. The most common characteristic of big data is that it's big. It's a large volume, and it's true. We just went over that. It's so big that you cannot simply open it in an Excel spreadsheet. There's got to be new methods, new technologies to manage these massive quantities of data. If we move on to the next V, you've got velocity. So this refers to fast data, real-time data, data arriving every second. So this can be a lot of the social media data, for example. On Twitter, you've got Twitter users tweeting every second more and more tweets. And Twitter has systems that are able to handle that data as it arrives in real time. The next V is variety. This one is very important, in my opinion. This refers to the fact that we now have many different types of data. Not just simple Excel spreadsheets, but we have photos, we have videos, GPS, etc. So we've got to have new ways to manage this type of data. So for you to get an idea, more than 80% of the world's data is unstructured. It's this new variety of data, whether it be videos, photos, music, etc. But less than 1% of all of this data, structured and unstructured, is ever analyzed. There's a ton of data left without being used, without being exploited. Now, when I speak about structured versus unstructured data, this is what I mean. We always had in the past structured data. It came nicely into tables, we can play with it, we can analyze it. But nowadays, most of the data around us is unstructured. It's coming in the form of social media data, of Word documents, HTML files, photos, videos, etc. Now we're going to return to the 5 V's because I've still got the 2 V's left in yellow, and they're just as important. The first one is veracity. So when we're working with big data, whether it be a large volume or different types, whatever it may be, we have to assume and accept that this data is not going to be perfect. Big data is not perfect. There's a lot of it. It's coming from many different sources. It may be coming in real time. So we have to accept that the data will not be perfect. But 99 or 98% is good enough when we're talking about big data. So often this acceptance of error in statistical terms is referred to as the margin of error or the confidence level. Now the last one is the most important of all. You've got value. Nothing else matters if you cannot find the value hidden within your data. Before embarking on any data initiative, you've got to be sure that you have your business objective defined, and you've got to stay on track to make sure that you're getting the right value from that data that you expected. Now, like I said, we're always starting with data in our businesses, but the big data revolution is less about collecting more and more data. It's about collecting the right data. So we're collecting data, documents, pictures, videos, etc. But the data itself is meaningless. You've got to clean it, you've got to organize it, and you've got to apply contextual support. That creates information. Now with the information, you've got to apply it to real life to really get a value from it, and you've got to create your new ideas and beliefs. That's how you create knowledge. And lastly, with that knowledge, you need to take action within your business. Of course, the last piece is action. Now, I'm going to tell you how Netflix does this, because for me, it's one of the easiest and best examples for you to see how they're taking advantage of these steps of data. So Netflix collects a ton of data on their users, on their viewer habits, and they analyze this, they clean it to create, to understand the actor and producer success rates, to correctly classify their movies, to do sentiment analysis, and many other things. Now with this newfound information, they apply it to real life. They apply it to their business, and they understand which combination of factors contribute to a box office success. Which factors mean that a movie will be successful. Once they have this is knowledge for them. They can take action on it, and they produce a new movie using a combination of factors that they predict will be successful. So Netflix is doing it the opposite way as the rest of the entertainment industry. Netflix produces new series, new movies, based on their data, rather than based on gut feelings and intuition. And if you've noticed, Netflix has had a lot of success doing this. So it's the right way. Now to the right, you'll see more examples of where big data is being applied across different industries. So for example, in manufacturing, it's improving demand forecasting. In healthcare, we've got now better genome mapping, DNA sequencing. In banking and finance, it's used to improve our fraud and risk models. And finally, in retail, it's used for better target segmentation of customers. So you can see here, it's applied to many different industries. But a lot of times, when I show this slide, people wonder, and people ask me, okay, but a lot of these things have been going on for a long time. It's not new that banks are now using data for risk and fraud protection, for example. So what makes all of this big data now? Why is it such a hot topic when it's been going on maybe for decades? So let me show you an example within healthcare, why this is now so important. So if we focus on healthcare, we focus on DNA sequencing. The first sequencing of the whole human genome was completed in 2003, and it cost roughly $2.7 billion over 15 years of work. By 2006, the cost of DNA sequencing was down to $300,000. Today, it costs less than $1,000. So you can see here, thanks to advancements within big data, new technologies, new systems, we can manage these massive amounts, these complicated pieces of data to do incredible things like this. And the price keeps going down and down to the point where one day, all of us can get our DNA sequenced if we want, and we can even have personalized medicine, for example. So a lot of pretty amazing things await us in the near future. Now, here you see a lot of examples of different companies, big ones, that are using big data. I spoke about Netflix, and you know, of course, LinkedIn, Facebook. They use it, for example, to, they all have recommendation engines to suggest who you should add next on the platform. Google, of course, the warehouse where they store everything, it's a massive big data engine that's able to give you results within seconds when you search for something. And even companies like Macy's. Macy's is an American retailer, very large. They adjust their prices in real time, depending on supply and demand. So all of these massive companies are using big data to their advantage. But all of these are very big companies with enough money and resources to invest. What happens to the small companies? The good news is that they can still stay in the game. That's the good thing about big data nowadays. The prices are coming down for new technologies, and small companies can even take advantage of it. I'm going to give a couple examples. This first one is my favorite example. I'm going to tell you about Makoto. Makoto is a Japanese cucumber farmer, and this is a true story. So Makoto and his family, they have a cucumber farm, and they have to classify the cucumbers into 9 different groups, 9 different classifications. And it's very important, the different groups of cucumbers, because each group calls for a different price at the market. So they need to be very careful and accurate. Makoto's mother spends 8 hours a day classifying these cucumbers for their business. So Makoto decided to use TensorFlow, machine learning from Google, and built a machine that can automatically classify the cucumbers into the different groups. And it works. His mother now doesn't have to classify cucumbers for 8 hours a day. And this is a true story, so please feel free to Google it later because you can see the video of his machine doing this. Now, my next example is about AucNet. AucNet is an auction website for people to buy and sell used cars. And in their case, posting a car to auction can be very time-consuming because you have to upload 20 different pictures with labels like front, back, tire, etc. It can take a little while. So they decided to use, again, powerful machine learning to classify these pictures of cars as they're uploaded to the website. And it works because now they have decreased this step in the time to auction from 20 minutes to 3 minutes. So it was a great success for them. And my next example, you all know McDonald's, but you probably don't know Apprinti. So in their third tech acquisition this year, McDonald's acquired the startup Apprinti. Apprinti's mission is to be the world's best AI-based voice recognition system, offering a human-level experience. So McDonald's was quite impressed with their technology, and they've decided to incorporate Apprinti's software into their drive-thrus in an effort to streamline and optimize operations, so the drive-thrus can be done automatically. Apprinti's software uses machine learning and speech analysis to directly convert voice to text. So a new form of data, because we're working now with voice data. In my last example, small indigenous languages are dying out around the world. And the Maori language of New Zealand is no exception. So Kupu was launched. This is a picture-taking app. You can download it yourself. You take pictures, and it uses image recognition software. So as you're taking a picture, the software automatically recognizes what the picture is of, and it gives you the Maori word for that picture. So you can learn the language. Here you can see an example of it. This is what would happen on the app. So you take a picture like this. In this case, it's a child smiling, laughing. And the app automatically recognizes this. It puts smile and the Maori word for it, which is mene mene. So up until now, I've reviewed a lot of different use cases. You've seen how a lot of companies, big and small, have used big data for their business. But the truth is that a lot of businesses have gotten left behind. It's been quite complicated to keep up with the changing trends because everything happened quite fast. You can see it here. Big data appeared more or less in 1997 with the start of unstructured, large, real-time data. Later, big compute came next. This is the start of distributed processing and cloud computing. And finally, big model. And when you pair big model, which is advanced algorithms, with big compute and big data, you get computers that are capable of beating the best at Go or chess or driving autonomous cars. So what's next? What can we expect next? We can look forward to great advancements in industries all around us as fields like machine learning and artificial intelligence take advantage of big data to reach heights that have never been seen before. The world is one big data problem. What are you going to do about it? Thank you very much.